Okay. Yes, my last name means like tenant farmer. Really? It's not very exciting.
My name means mill worker.
Mill worker, of course. Yeah. I think it does. Usually right there. Yeah.
Turkey's a great conqueror. Yeah. They had a big empire.
That's true.
It was the Ottoman Turks.
Yes.
The Turks. Mm-hmm. They make delicious food too. Okay, so how do we read a graph like this? You guys have never done stem and leaf plots before?
I have.
Daniel, you know?
Yeah.
Okay. Oh, you just know. You're just saying that you know how to read it.
Say it?
Oh, yeah, that'd be great.
Oh,
Please
okay.
explain. Yes.
Is it like the 5 and the 0 is 50 and then the 5 and the 8 is 58?
Right. Okay. So the leaves, right, represent individual data points, and they're like, in this case, we're normally in a stem and leaf plot, you're given a key. All right, some sort of key about how to do it. Okay. But the leaves are all like going to be ones digits here. Okay, and the stems are all the tens digits. Okay. So Dylan. For example, when you see the stem of 5 and that has a leaf of 0, that means that 50 is a data point, as Daniel said. And then the 8 would be with the 50 as well, so we also have then 58. And so you can see how it goes here. The next number in order of our data set here would be what? 60. Yeah, 64, and then 68, and then 70, 74, 76, 82, 82, 82, 86, 86, I'll explain it here in one sec, 86, and then 90, 90, 90, 90, 90, 92, 94. Okay, so where did the 50 come from? Because we have a stem of 5, leaf of 0, so 5, 0. Okay?
6, 4.
Excuse me. And we also have a stem of 6 and a leaf of 4, so that's why we also have 64 as a data point. Okay?
What are these actual like stems and leaves, or these math?
No, it's just kind of like the symbolic kind of like meaning for it. It's kind of, I don't know. Yeah.
Hey, you never know, they might have that.
No, I hear what you're saying, and there are reasons.
And a leaf farm, right?
Yeah.
Right, exactly. Stem and leaf farm.
They slash down leaves.
That's right.
Sell
Sell those leaves. Probably went out of business though, because no one wants to buy leaves, but
them.
But it was a good effort,
Firewood.
Well, these are actually math test scores. You can see right here.
Yes,
it
I
says.
see that.
Okay, so now we have our data written out. We can do mean, median, mode, and all that stuff. Okay, so I'm not going to like necessarily go through that because I think you guys are comfortable with it. However, remember that the data is right there in the table, so you don't necessarily need to write the data out in order to do any of these. For example, you can just type in your calculator, 50, 58, 64, 68, start to add them all up kind of thing. Divide by 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 20. So you can divide by 20, okay? For the median, you don't need to write them out. They're already kind of in order here. You just have to count. So again, if I were to start here at the lowest number and at the highest number and just count in, 1, so there's the next one. After this 8, where should I go next? The 4, right? And count in there. And then I'll go up to the 8, down to the 0 again. And then from this 8, where should I go? Yeah, to the 0 right here, and then the 0, and then the 4 and the 0, and the 6 and then the 0 there. I know I'm kind of like in my own way. And the 2 and the 6. So once I get down from the 90, I want to go down to the 86, which is the next highest. And this, and then this, and I get down to 2 numbers in the middle, 82 and 86. So that means I got to add them up, divide by 2, I'll get 84. Guess I can write that in here. And then the mode is super easy to see. What's the mode here? 90. Yeah, 90. It's the one that occurs most often, so that's the 90 there. Okay. And the range is also easy to find here too. Again, it's just 94 minus 50, so it's going to be 44. I didn't do the mean just because it's going to take some time that I don't want to take to do it. Oh, is it? Okay, thank you. 80.2. All right. So that's how you read information from a stem and leaf plot. Okay. So I think we've got one on here that actually has us practicing how to do a stem and leaf. Nope, never mind. It's just reading. Oh no, here we go. Construct a stem and leaf. Yes. Let's go back to number 3 here real quick and just talk about that stem and leaf stuff. How to actually make one here. Okay. To make the stem and leaf, it is helpful to have the data written in order. It's not necessary, but it's pretty useful. You really do want to do it. Okay, so let's build our stem and leaf plot. So we're going to have stems and leaves. So make like a little T here. Stem, we'll write right there. Leaf, we'll write right there. Okay? So remember, the leaves should only have one number per data point. A leaf should only have one number per data point here. The stems, you can have the leaf should only be 0 through 9 as a number here, okay? Your leaf should only be the answers like 0 through 9, okay? That's the only thing you should have here. Here are your stems. You can have 0. You can have them be any number, really, okay? Any whole number, okay? And remember, the stems are like, well, anyway, let's go here, for example, 8, okay? How will we represent an 8 in a stem and leaf plot?
0, 8.
0 and 8. Very good. The stem will be 0. The leaf will be 8. Okay? And then, well, we've got 11, 13, 14, 15, 15. So we'll put a 1 for the stem. And then for the 11, we'll put a 1 here, and then a 3, and then a 4, and then 2 5s. And you guys get the idea. Then for the 20s, we'll do a 1, a 2, a 6, a 7, an 8, and a 9. Okay, and then for the 30s, we'll do a 1, a 1.
After the 9, nothing.
Well, there's no more 20s, are there, right? So that's why we stop with the 9. With the 3s, we have 1, 1, 3, 4, 5, 6, 9. And with the 4s, we have a 5. Okay, now, ideally with the stem and leaf plot, you put a little key as well, and you say, like 1 line 1 equals 11, something like that, just so that way people know how to read your stem and leaf plot. Questions on any of that? That's how you make a stem and leaf plot, okay? It just helps organize data. The kind of the cool thing is, too, if you turn the graph on its side, you kind of have a bar graph, don't you?
Yeah.
You have there's a bar right there, there's a bar right there. If you space the numbers out evenly, kind of thing, okay? You can see that we have the most grades in the 30s, then the next highest are grades in the 20s, the 10s. Are these grades? No, home runs, sorry. Most number of home runs was in the 30s, then the 20s, then the 10s, and then, well, the zeros and the 40s. So.
Wouldn't that be pretty bad if it was grades?
What's that?
That would be a really bad class.
Yeah, I know. Well, there might be points out of a certain number. Yeah, I know. Well, that looks like one of my college classes grades. Yeah. Back when I was in school.
Someone didn't collect my warlord.
It's okay. I'm gonna cut Liv's grade cut Liv's pay in half. What's half of 0? Nothing still. Yeah. Okay, that's fine then. All right. Okay, I don't want to spend too much more time there. So there's another stem and leaf right there. Again, you can see, we just read that, 44, 46, 47, 49. There's no 50s, so on and so forth. For this one, okay, this is called, I think, a frequency chart. Okay, you can see, again, there's 130, there's 231s, there's 432s, and so on and so forth. You guys can figure out the mean, median, mode from that. I just want to show you that real quick. Okay, questions on any of this? All right, so you guys can put that away for right now. I got another paper coming at you here in a second. All right, so go ahead and put that away for right now. Question? Oh, okay, that's fine. Ran out of space there?
Yeah.
Okay. Thank you for the heads up. Yes, I appreciate it. Otherwise, I suspect foul play. Okay. Let's see here. Yes, we're going to do some more practice here, but I'm not sure. Okay, let's do this one first, I think. Oops, that one is only one-sided. That's weird. Okay. Oh, that goes there. That's why. Okay. 2, 3, 4. Take one cuss down there, please. Yes.
I just want to make sure that so current the 66.4 and 7.6 into a fraction.
Okay, you can leave it like that. So yeah, so your final answer should not have any decimals. It should be. And you can leave it then with like logarithms in it and stuff like that too as your answer.
Now he's making fun of me
N
and you.
equals
Oh,
and then
okay, never mind.
expression.
He said,
okay?
Thank you so much.
I'll tell you later. Yeah, look. What did he say to you?
He said, I will be this. He said you're really ugly.
Okay.
Yeah, Mark, did you say that? The world will reverse that. He was saying that to me.
So
We'll talk about how data collects.
what we're going to talk about now, okay, is a continuing with our data analysis, okay, and we're going to look at another kind of graph, another way to display data called a box and whisker plot, okay? So a box and whisker plot incorporates stuff that we already know. So for example, median, we're going to use median, okay? But it also incorporates other things too, and it allows us to both identify a center for our data, but as well as kind of the spread. So it's a graph that kind of shows both the center of our data and how spread out it is. All right? So if you look here, we've got some data, okay, and I'm not sure, well, this is in human beings, but I'm sure we all have different lengths of bones in our bodies here, but this is maybe an average or just some particular person or whatever, okay? So exactly right, but I hope they put them back when they were done with them, you know? So probably not though. Probably, yeah, or ground them down to make Jello.
What?
Yeah. You know that Jello's made from bones? It is. It makes you wonder.
Bugs.
And bugs? No, bugs is the red dye. That's why the red dye used to be made from bugs. I don't know if it's still made from bugs, but
What kind of bugs do they make it from?
these like beetle-looking things. Yeah.
It's like beetles.
They grind up these beetles that were dried out.
Farmer beetles.
Yeah. I think that's why they call it. Have you ever been to like camp before? You know, and sometimes they like make like the Kool-Aid drink and they call it bug juice. You guys, yeah, I think that's why they call it bug juice, because I think it was used to be dyed by bugs originally.
What bones is Jello made from?
What?
Cow bones.
Whatever bones, I guess. Yeah, I mean you can do whatever bones, but yeah. Yes.
That's horse hooves.
Yeah, right. And then the glue, yeah, the horse hooves.
Glue is made from horse hooves. Jello is made from cow bones.
Yeah.
If you ever drank
Crazy, huh?
Elmer's school glue, you can definitely taste it. It tastes like
You can taste the horse hooves. Yeah.
Did you say? Did you have it?
what? Drank glue?
Styler.
Yeah. It's
Yeah, it's great. It's great. You never drank glue before?
You're missing out.
That's right, you're missing out.
It is non-toxic, but I would highly recommend you don't drink
Try
it.
what?
You'll get a little
Drinking
sticky.
glue.
Oh,
That's right.
Oh, do not.
Okay.
No, it's too late.
It sticks to your ribs, guys. So let's keep going here, all right?
How does it get to your ribs?
I'm just kidding. Anyway. So we've got some lengths of bones here, all right? And we're going to put them in numeric order first before we try to make this box and whisker plot, okay? So numeric order looks like our lowest number here is 23, followed by 24. And let's see here then. 26. And then 27.5. And then 36.5. And then 40, 49. And then finally 50.5. Okay. And we're going to plot some of these numbers. Okay, so the box and whisker plot requires us to identify 5 numbers. Okay, oftentimes I'll refer to it as the 5-number summary. 5-number summary. Okay, 5 numbers. The 2 extreme ones are going to be our lowest value and our highest value here. Lowest data value, highest data value. So what is our lowest data value? 23. So if I'm going to graph that here, and by the way, we're going to graph in this white space above the number line here. So I'm going to graph 23, so I got to locate. So there's 20. And what does it look like our tick marks are counting by here? Yeah, that's the 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 30. Okay, that's perfect. So 1, 2, 3, there's 20. And I'm going to put a little dot right there for our lowest value. Okay, and then simultaneously to that, I'm also going to put a dot for our highest value. What's the highest value? 50.5. So here's 50. There's 51. So we'll just go right smack in the middle and put a little dot right there.
In the middle of 50, 51.
Yeah, because 50.5, right, is right in the middle of those two. Okay, I'm going to maybe even draw like a little arrow here just to show that's 23 and that's 50.5. Okay. Now, 5-number summary, right? So we took care of the lowest and highest. The 3 numbers that are in between those, okay, the 3 other special numbers, well, the middle one is the median. So we have to find the median of this data set right here. Okay, so how do we find the median again? What? It is the what? Middle number. Yeah, you can cross them out if you want to. I'm just going to count in. So I'm just going to count in here. So, okay, so the median is between, right?
between 23 and 26.
Between 27.5 and 36.5. Be careful. You count. They have to be in numeric order, Alex. Do it this way. Put it, so that's okay.
Wait, where did you get those numbers from? Is that from the chart?
These are from the chart. I just put them in numeric order. So count into the middle, and it's between. So I'm going to put like a little line here for myself, and we're going to, what are we supposed to do when we get two numbers in the middle?
Add them up and divide by 2.
Add and divide by 2. Add and divide by 2. That's right. Okay.
I got 32.
Is it 32 exactly?
I think so.
Exactly.
Yeah,
Okay, about 13 minutes remaining for you, Laura. Oh, is it 13 exactly? Okay. So then, wait, it can't be 13.
Oh, it's not said 32.
Oh, that's Mr. Wid. All right. Pay attention, Mr. Wid. So 32 is our median. I'm going to put MED above that. 32 is the median. And so we're going to locate 32. So there's 30, 31, 32 is right here. Okay. You can put a dot if you want to, but really ultimately we want to put kind of like a line, a little segment like that. Okay, a little segment like that. Okay, remember this is called a box and whisker, and you'll see where the box is going to come from here in just a second. Okay.
I remember working on this
You do remember doing this kind of thing?
a while ago.
Okay, so we've taken care of 3 of the numbers. Lowest value, highest value, lower extreme, upper extreme, median. For the other 2 remaining numbers of the 5-number summary, okay, so again, that's 32 right there. I'll put
Is
that.
it like the median?
It's the median of the median. Okay, you'll notice that the median splits the lower half of our data and the upper half of our data, right? Median splits it exactly in half. We have 4 on this side, we have 4 on this side, right? So we're going to find the median of this lower 4. We're going to find the median of this upper 4 set of data. So this lower 4, let's find the median. So start with there. 24 and 26. Uh-oh, we get down to 2.
25.
25. Add them up, divide by 2, 25. This is called Q1 for quartile 1, or you could also call it the lower quartile. Lower quartile. You see that word quarter in there for quartile, right? The quart, because now we're dividing our data into 4 groups, and so that's going to be one of the. So 25, there, right here, there's 25, and I'll put another little line. Lower quartile, median, lowest, I'll put that here too, highest value. All right, and so let's find the median then of the upper set of data.
Upper quartile.
Yeah, exactly right. It's called the upper quartile. So we're going to count into the middle. So these 2, then these 2. 40 and 49, add them up, divide by 2. Now, 40 plus 49, divide by 2, 44.5. And we're going to call this Q3, and that's the upper quartile. Now, I called this one Q1, I called this one Q3. Where do you think Q2 is? That's Q1, lower quartile. There's Q3, the upper quartile. Where do you think Q2 is? It's the median, exactly right. Okay? So from here to here, this is the first quartile. It's the first quarter of our data. What's that?
Where's the higher quartile?
Upper quartile?
Upper quartile.
Yeah. Q3. And so what is it? Oh, the value you're saying? Sorry, 44.5. My bad, 44.5. I didn't write it.
Will we do a line or?
Yep, another line then. So 1, 2, 3, 4, halfway between 4 and the 5 there, and another line right above it. And then now we connect them to make a little box. Okay. Upper quartile. But you can see our Q1, Q2, and Q3 break up our data into 4 quartiles. There's the first, second, third, and fourth. And then you connect the little dots to the box by using a little whisker. There are the whiskers.
Very.
Okay? It's like a cat. Meow. Okay?
Will we have to be using this way?
Some? Mm-hmm. Mm-hmm. Yes, you can do that. Yep. Okay? Questions on any of this? again, I said the first quartile is right here up to our Q1. So this whisker is a quartile right here because it goes from our lowest value to Q1, the lower quartile there. Okay? So if it's a quartile, what percent of our data should be in this quartile? What percent is a quartile? A quarter, or what percent though? 25%, yeah, 25%. So 25% of your data is in this whisker. 25% of our data is in this part, the left part of the box. 25% of our data will then fit in the right part of the box, and 25% of our data fits in this right whisker. So first, second, third, fourth quartile. Okay? So there's your question. Oh, yeah, what? Go ahead. Sorry. So go ahead, guys. Try and answer these questions right there. Okay? You already have some. We already calculated. So go ahead and try and answer those questions real quick. Yes, that would be a good final form. Either this one or this one's okay.
What's the?
Because they're equivalent.
What's their
Sure. So I would say maybe try recalculating. Okay, sorry. Hold on. Answers first, and then we'll get to your question. Okay. Which is the longest bone? The femur. Okay. And that's true in general. Your femur is your longest bone. You guys know where your femur is?
Right here.
It's this one right here. Pretty close. It can bear the most weight too, like as of all your bones as well. So I think it can hold I heard if it's properly placed, it can hold like a ton or something like that. So it's pretty crazy.
Oh, wow. It hurts so much.
Yes, but you trying to hold up the ton, well, your rest of your body will crush. But I mean, your femur will stay okay though.
That's probably why it would hurt so bad if you rip it.
Yes, it's very serious if you break your femur. Yes, very serious.
Does it die?
What cars are made of femurs? Yes, yes. A femurari. You ever drive one of those? Yeah.
They're pretty cool.
Yeah.
My uncle has one.
Yep. He must be pretty rich.
No.
Oh, okay. He just made he took femurs and made one.
No, let's just say he legally acquired. He acquired.
He acquired them, right? Just forget the legal part. Okay, what's the first quartile of the given data?
25.
Yeah, we said 25, right? What's the median?
32.
32. What's the length of the shortest bone? Yeah, 23. It's in the graph right there. 23 inches. Inches. And then, sorry, yes, 44.5. Okay, Mark, you need to go to the bathroom. Is that what you were asking about?
Yes.
Okay,
Can I
go
go to the
ahead.
bathroom after Mark?
Yes.
Can I go to the bathroom after Alex?
I hope so. Yeah, if we have time. Yeah. Okay, so let's turn to the back. Turn to the back. Okay, so we did one together. All right, so time's up there, Laura. So you just want to finish up that last question you're on. Okay. You did finish the other one, though, right?
Yeah.
Okay. So you just finish up that, and we'll have you move on. Okay, so let's do this one here together. All right. So we're going to try and make a box and whisker plot here for, again, some home runs with Roger Maris's home run totals for his 10 seasons when he was in the American League. Older baseball player there. Okay. So Ben. Okay, if we're trying to make a box and whisker plot, first thing we should do is put the numbers in order. Are they in order?
No. Yes.
I think they are actually, yeah.
Yeah.
Kind of works out nice. Okay. So then we got to find some important numbers here, okay? So we're referring back to here, okay? We need 5 numbers, okay? So the lower extreme, what's the lowest extreme value here, Ben? 8, okay? So that's our, so I'll circle that one. That's important, okay? And then the upper extreme, Ben, what's that? 61, okay? And then what's another important number we got to find here? The what?
The 2 middle ones?
Yeah, well, we'll find the median first. Yeah, find the median first. Let's count in. So 8 and 61, and then 13, 39, 14, 33, 16, 28, 23, 26. Okay, Ben, we got to 2 numbers in the middle, so what do I have to do?
You have to add them up, which would be 49.
Divide by 2, 24.5. Okay, and that is our median. Okay, thank you, Ben. We'll go to somebody.
Find the median and
So, did we use the mean or the mode on the front?
we use the quartile.
Yeah, we just used the median kind of stuff there. So, in other words, no, you don't need it for a box and whisker. Is it helpful to know those things? Yeah, it can be. It can be. But we're not going to do that right now. Okay. Okay, next, let's go to Daniel. Good luck in the track meet today. Run fast. All right.
Run fast.
Let's go to someone who's here. All right, Liv.
Oh, okay.
All right, so we've got the median. What else do we still have to find? What should I do now? Now that I found the median there. All done. Thank you. Well, do we? We don't yet, right? So we're going to take our lower set of data. Again, we're going to count to the left of my median here. So start at 23 and 8, and we'll find the median of this. So 14. So 14, that is our lower quartile, or Q1. Okay, and the upper set of data. 33, yep. Not too shabby. Q3. Whoops, not lower, Mr. Wid. Upper quartile. And remember, that's Q1 and that's Q3 because Q2 is the median. It's the median. All right, Laura. Sounds good. We'll see you later. Tuesday, I guess, right? And do some more.
Yeah, there's one.
That's right. Oh, that was your time.
Oh, well done.
Well, anyway, you finished. So good. Yep. Okay. You're welcome. We'll see you.
Have a good one.
You too. Okay, so we've got our numbers. Now we got to make a number line here. Oof. And our number line has to count from what to what? Our number line's got to go from 8 to 61. Okay, so let's see if we can do this here without being too crazy. I'm going to draw it pretty wide. Okay, I'm going to start at 0. Your number lines don't have to start at 0, but I think that's probably not a bad idea. I didn't draw a very straight number line there, but oh well. Okay. We got to go up to 61. So let's maybe count by tens. So there will be 10, 20, 30, 40, 50, 60. And I guess we'll go up to 70 because we do go to 61. Okay? And then if you want to, you can put tick marks in between to count for the ones, right? So like 1, 2, 3,
This is gonna be a
4,
perfect graph.
5, 6, 7, 10. You don't have to. But it's not a bad idea. Whoops, I put too many. Okay, I'll just do 1 to 60 because that's all we need. Okay, so 1, 2, 3, 4, 5, 5, 5. I'll make the tick marks for the tens ones really big, and I'll also make the 5 ones really big because that can help, kind of like orient. 1, 2, 3, 4. There you go, like that. It kind of helps kind of differentiate between the different numbers there. Okay. Now we're just going to plot our data. So 8. Put a little dot above the 8 and a dot above the 61. Okay, dot above the 8, dot above the 61. I'm going to write their numbers above them too, just so I can have those to refer to. 14 is my first quartile, so there's 14 right there. Okay, the median's at 24.5, so there's 24, there's 25, so halfway between. And then the upper quartile is 33, 1, 2, 3. And then connect the lines to make the box, and then the whisker, and then the whisker on back. Okay. And again, remember, maybe I should even write this here too. This is the end of quartile 1, there's the end of quartile 2, there's the end of quartile 3, and then quartile 4, well, it ends up here. Okay, it ends up there. So the first quartile is the whisker, the second quartile is the left part of the box, and it ends at 24.5. The right part of the box is the third quartile, and then the right whisker is the upper, or the fourth quartile, the last quarter there. So 25% of your data is in that whisker. 25% of your data is between these values right here in the left part of the box. 25% of your data is between the 24.5 and 33. And then 25% of your data is between 33 and 61. Okay? That's how we can interpret that. All right? Questions on any of these? Okay, we're not going to worry about any outliers for right now, okay? But let's go ahead, because there is an actual calculation. There's a formula to find outliers. We're not going to worry about that official formula. But does it look like, just from your own opinion, that we might have an outlier here?
Yeah.
Okay, which one looks like it might be an outlier? 61, right? And again, visually, right, if you look at the numbers, maybe it's not so obvious, but visually you can see that 61 looks very far removed from the rest of the graph there. So perhaps that 61 is a outlier, but we're not going to say it is for sure until we come up with a way to calculate that, and I'll show you that later. Okay, but there's the box and whisker plot, at least for that. Alrighty. So I got one more thing I want us to work on here together, and then yeah, and we'll see how far we get here too. Okay. So you might want that handy in just case you need to. Okay, we won't worry about making too many more box and whisker plots right now just because they take so much time. What we're going to do now is answer the questions. About box and whisker.
I go, Mark's back.
Yes. Okay. Nah, you don't have to, I don't think. It doesn't say use complete sentences, so we'll be okay for that right now to not do it. Okay, so let's look here then at a box and whisker plot that's already constructed and just use it to answer some questions. Okay, so here's our box and whisker plot. It's very important that when you are reading a graph that you take in all the information that's given to you here. So for example, this box and whisker plot has no meaning unless we read the title here. It says it's the ages of people eating at Glory Days. Okay, Glory Days is a restaurant, you guys know, there on 15. It's got TVs everywhere. Okay, and then you can see, you know, some different dots and stuff like that. Okay, remember that this dot represents the what? the smallest value, okay, lowest value. The lower quartile would actually be like this, or yeah, to right here, okay? So yeah, what does this bar mean? It's Q1, right, or the lower quartile. Okay, what does this bar mean? Median. What does this bar mean? Remember, this bar was lower quartile or Q1, so this bar is going to be what? Upper quartile or Q3. And then finally, what does this piece, this little point mean right here? It is the highest value, right? The highest value. So it's the oldest person, in this case, that is at eating at glory days right now, or at that time when they did the observation. Okay? Now, I want to be a little bit careful here. The question number 1 asks, what is the age of the youngest person in the restaurant? That's not the graph that we have. The graph that we have is the youngest people, is the ages of people eating at glory days, right? So there might be a younger person there that's not eating that wasn't included in this data. So it probably should say, what is the age of the youngest person eating in the restaurant? Okay? So, who's next in line after Alex? Dylan. Your freedom awaits you, Dylan. Okay? So, what is the age of the youngest person eating at the restaurant? 5. Yeah, maybe you could say 4 there. I can see what you're saying. You could argue 4. So maybe we'll say like 4 or 5. Maybe it depends on how you want to, if you want to interpret that as they really meant to be less than 5, or if it's just sloppy graph making. 4.5. I can see 4.4, 4.5 if you like. Sure. Okay. All right. What's the age of the oldest person eating in the restaurant? 30. Ugh, that is old. What's the median age? I'd say about 23. Okay. What is the range of ages? Oh, yeah. So we would have to take the, how do you find the range again?
30 minus 5.
Yep. Highest minus lowest. So again, depending on what you say, you're going to say then 25 or 26, depending on, whether you use the 5 or the 4 there. Okay. Ooh, what's the interquartile range? So the range is highest minus lowest. What do you think the interquartile range is going to be? Tyler, what do you say?
I think the interquartile, like the median, so you get the median, which is 23.
Huh?
Drop back one, you get like 19.
Okay, so you're saying do the median minus the lowest value. Like that? Okay. Matt, what were you going to say?
Like the interquartile range?
Interquartile range.
Take the lower quartile, the lower one to the upper, and just in the middle.
So, Tyler, you had the right idea. You still want to do a bigger value minus a smaller value there, but it's which two values? Well, because it's interquartile, we're going to use the Q3 minus the Q1 there, okay? So I'm going to abbreviate this IQR equals Q3 minus Q1. Okay, so you have the right idea, Tyler, but just it's the Q3 minus Q1 there. That's all. Upper quartile minus lower quartile, which is, yeah, it's going to be 25 minus, what are we saying the lower quartile is?
15.
You want to say 15? Okay. 10. Now, the interquartile range is also helpful because remember, the range describes how spread out our data is. The interquartile range also describes the spread, but it's the spread of what percent of our data? What percent of our data is represented by this entire box? 50. Remember that one side of the box is 25, the other side is 25, so the total is 50. Okay? So the interquartile range tells us the spread of the middle 50% of our data. It can be helpful. All right, 2 more questions here, we'll stop. What is the mode of this data? You don't know? The answer is we can't tell. The box and whisker plot doesn't give us that answer. So we can't tell. Okay? What's the mean of this set of data? We can't tell without all the data points. Okay, when we come back, we'll answer the rest of these. I'll stop right there, okay? We won't be no homework for the weekend. Sorry. Sorry. 3-day weekend. Yeah.
Maybe more.
So 3-day, maybe. Well, I doubt it, but yeah. So try to enjoy your weekend without any homework to work on.